In this podcast, we will characterize and diagram the motion of a particle under rectilinear motion with position given by S of t equals 5t all over quantity t squared plus 1, where t is greater than or equal to 0. The first thing we need to do is find a velocity function, which is going to be the derivative of the position function, and this being a quotient, we will have low d high minus high d low all over the square of low, and a little bit of algebra applied to the numerator yields that we have 5 times quantity 1 minus t squared. The denominator, of course, is t squared plus 1 quantity squared. We then want the acceleration function, which is going to be the derivative of the velocity function, and for the sake of brevity in the podcast, I won't show the work, but this turns out to be 10t quantity t squared minus 3 all over t squared plus 1 quantity cubed. It would be good for those of you who have the time to verify that. It's good practice. Now we need to know locations of sign changes and so forth for the velocity and the acceleration, and we'll first take note of the fact that we're beginning here at 0. And if we look at the velocity, we find that it's got zeros at 1 and negative 1, and of course we only care about positive 1. So there's a 0, and upon a little bit of reflection we find that the signs are positive between 0 and 1 and negative thereafter. So this particle is going to begin its life moving to the right, and it's going to then stop at 1 and change direction and continue for the rest of eternity to the left. And if we look at the acceleration, we find that it's 0 at time 0. It's 0 again at time square root of 3. It also has a 0 at negative square root of 3, but that doesn't concern us. And the signs upon inspection work like this. So what we have is a particle that's going to be moving to the right and then to the left. It begins with a negative acceleration that then changes to positive at the square root of 3. So in terms of its speeding up and slowing down behavior, from time 0 to time 1, signs are opposite and our particle will be slowing down. From time 1 to time square root of 3, the velocity and the acceleration will have the same sign and our particle will be speeding up. And after the square root of 3, we'll again have opposite signs in the velocity and the acceleration, and so our particle will be slowing down. We want also to know what the position will be at these various times of importance. First of all, time 0, because that's when the motion begins. Time 1, because that's when we change from moving to the right to moving to the left. And again at time square root of 3, where we switch from speeding up to slowing down. And if we put these values into the position function, we find that at time 0 the position is 0, at time 1 the position is 2.5, and at time square root of 3 the position is about 2.165. And so in diagramming the motion of the particle, we're going to want to use a scale that captures these 3 values, and it seems to me that if we go from 0 to 3 by 1s, we're going to get a pretty good picture of how this thing is moving. So then we want to identify the position at the initial time of 0, and we'll just make a little dot there, and we'll make a note also that this is occurring at time 0. And then we need to begin to move, since the velocity is positive initially, we need to move to the right until time 1, which gets us to about position 2.5. So our particle will be cruising along rightward, and then we'll at time 2.5 change direction and head afterward off to the left for as far as you like. We'll want to make note of the fact that this change in direction occurs at time 1 and that the particle is instantaneously stopped at that time. Now from time 0 to time 1, as we said, the particle is slowing down, and so we'll indicate that, maybe a couple of arrows so everybody knows which way we're going. And then we're going to continue to slow down until time 1, Then we're going to speed up, but only until time square root of 3 when we're going to be at position 2.1 something. And so that's maybe about here. So that's at time square root of 3. And in here we are speeding up. So we'll make a little indication there that we're going faster, and then afterwards slower all the way on out. That concludes our analysis of the position of our particle under rectilinear motion with s of t equals 5t all over quantity t squared plus 1.